Well, hi there, and welcome to week 7 of cis204 Unix Shell Scripting and Utilities. And this is the first of 3 parts of the online lecture. So let's get this cheesy device out of the way here and jump in. First thing I want to do is talk a little bit more about interactive bash, and in particular what I'd like to do is go back and do a review of last week where we started the process of talking about interactive bash. Again, bash is the born-again shell, and like anything in the Unix and Linux environment, if it looks like a pun, if it walks like a pun, if it quacks like a pun, it's a pun. Puns are good. The release 2.x and above of the bash shell added C shell and K shell features, and it is also POSIX compliant. The bash shell is also freely available. It's open source, and it is subsequently nearly universally available because of those features. Everywhere I have been and have dealt with programmers or system administrators using Linux or Unix, they use bash as their shell. Very few of us still have any hankering for K shell as I do, but I've learned to love bash whether I wanted to or not. So bash is universally available and almost universally used. The bash shell uses a number of startup files that will enable systems, actually settings for your shell environment. Those are the environment variables, and the startup files are sourced, and that basically causes the settings in those files to take effect. The /etc/profile is a system-wide initialization file, and it's normally set up by system administration for whatever machine that you have a login on. And very often those etc profiles are set up based on corporate standards. So the sysadmin says has been told that you have a certain mail policy, that you have a number of attempts policies, or you've got certain messages of the day that have to be run so that you know that Jim Doe is out of the office today, that type of thing. Those things can all be set up to be kicked off based on information in the etc profile. Those are for every user that logs in, basically. That etc profile is set up for anyone that logs in. Now, to personalize it, you'd end up using your home directory's .bash_profile. That's in your home directory. It allows you to customize the shell. Unfortunately, it doesn't allow you to get rid of the stuff that the system admin stuck in the etc profile. If when bash starts, it looks for the .bash_profile. If that doesn't exist, it will look for .bash_login. And if that doesn't exist, it will look for the old K shell standard, the .profile that's sitting in your home directory. And it will also check to see if there's a .bashrc file, which it needs to source. Then it looks for a .inputrc, and if it exists, and it doesn't by default, it will be sourced. Now the fun thing is this contains variables that customize keystroke behavior and settings that bind strings, macros, and control functions to keys. So I could set up my F function keys, F1 through F12, for example, to run common commands or command structures. So if I do ps space aux and pipe that to grep for whatever, I can set that up in a control key, hit the control key, it runs that whole complex instruction with a single key. And that's in keeping with the notion that Unix was built by people that wanted to make sure that they didn't have to do a lot of typing. Then the other thing that showed up, and we've seen this in class, is the set-o options allow customization of the shell environment. And there's also the shell opt, SHOPT, which is a superset of the set options. So let's move forward a bit here. So the source command, which is at sourcing the file, is a dot or a period. It runs the commands in a script, but in this case it will set a path or a set of environment variables or those keystrokes that you wanted to customize, that type of thing. It doesn't create a new shell to do that. When you use the dot space file name to source the options that are sitting in that file, it will do that in the current shell that you're in, as opposed to setting up a child shell, a child process, and then running it in the child and not making it available to the current. So another piece of this that we talked about last week is the commands will run according to the type in the following order. So let's say that I have a command that I call more. I've aliased my command more to actually be the command less. When I run more, it actually runs a less command. So when I type more on the command line, Bash will look to see if there's an alias for more, if more is an alias, and it does. It finds it and it says that's less, and it will use less instead of my more. Now the fun thing here is more is actually a command. It actually exists. It's a executable. The way Bash works, it looks to see if there's an alias for more before it looks to find the actual executable more, and it will run the alias first. So it will never progress beyond the fact that I have aliased more to equal another command called less. And then it'll look to see if less has been aliased. Well, anyhow, we can go on like that for a week. So the shell options are similar to the set-o options. It comes, the shell opt shopped comes with the newer versions of Bash, the 2.x plus of Bash. They offer more options than what is available in the set. The command syntax is show-op-u or show-op-s. The S sets the option, the U unsets the option. And if you use the shop-p, it will show the status of the options. And so let's do that right now while we're hanging around and shooting the breeze. Okay. So if we go back, there's shop-p. You see there's a -u auto CD. Unset, there's a set expand aliases, there's the external quote, there's the force underbar F ignore, there's the set interactive comments. So you can see the various things that are set and unset. Okay. There are 3 built-in commands that can change the order of command line processing. In other words, I don't want you to run aliases first. And that becomes important when you're building a shell and you're trying to use a function that can very often be aliased. So if I run, for instance, alias, see if I've got, there are my aliases. So alias more equal less. Okay, which more, bin more. Okay, alias, there's my more equal less. Okay, so what happens if I want to run more on a file? Now let's take a peek here. Let's see what files I've got here. Okay. Okay, well that's simple, right? Hey, that looks an awful lot like less. What if I do this? Now it restricted. The command will keep the alias and functions from processing. In other words, the only thing that will happen is it will say, no, I'm not going to process an alias. I'm going to find more as an executable. And that's what happened when I ran the command space more. When I just ran it, more test underbar test, right? I get that, which is less. Okay. Built-ins. If you use the command built-in, it will only process shell built-ins. So if I do this, less is not a shell built-in, it won't run it. Okay. Enable allows me to turn the shell built-ins on or off. So which PWD, there it is, it's in bin PWD, and let's do a built-in, and up. Yep. Well, come back to that at some other point, but so the built-ins, the enable will turn built-ins on or off. So after a command terminates, as we know, you'll get an exit status. The status can be a number from 0 to 255 with the 0 reserved for successful completion. So what was the last command I ran? $? Again. That was that goofy function. Let's see here. Let's see what happens if I do that. Okay. The clear actually, the control L did not actually run as a command. Now that's special. So the type tells you what kind of a command you're running. And this is where I was going after with this PWD. PWD is a shell built-in. Okay? So, moving on. I want to take a couple of seconds here and talk about Project 2. So I got a number of right answers for Project 2 in the past. This is a fun one. This grep-VE, no login, shutdown, halt, or sync at the end of the line. And then that's from the password example. Take everything out of that, send it to the cut with the fields being, I want field 1 and I want field 5, and the delimiter for this is the colon. Then I want to do a grep-V on anything that has a colon and some other character, and then on the word boundary a lowercase a to z. So in other words, give me everything that has a colon, a number of characters, a word boundary, and then lowercase a to z. So that got rid of the no uppercase name. And then the last piece of that is to transform the colon into a space. Okay, so the second one does a similar thing. The grep-VE, sync, no login, halt, password example, cut-D, the delimiter, and then notice it used the POSIX --output delimiter equal, so I don't have to use the transform command at this point. It does it with the output delimiter equals space. Notice in both cases with the transform or with using the output delimiter option on cut, I have to have the space surrounded by single quotes. And then I'm going to look at everything that comes out of that, looking for a space and a capital letter. Cool, because that means on that field 5, I'm going to have a space and a capital letter. Okay. So the next one is grep for bash. Somebody figured out that that every login here was bash if it was a user login. Did that from the password example, cut based on the delimiter files 1 through 5, and then they used a sed command, the stream editor, to get rid of the colon. So sed substitute the colon with the space globally. And then the last thing they did was they looked for something that was at the beginning of the word. Pardon me. They looked for an A to Z, not A to Z, and some other characters, a space, and then a capital A to Z. Oh man, something like that, because in reality I believe what we're looking at there is beginning of, well, no they can't, because I've got 1 through 5. So yeah, that's exactly what's happening here. Is this right here is beginning of the line. Okay. So the last one is an egrep-v, which is the same thing as a grep-v capital E. So an egrep-v, and I'm looking for no login, halt, or shutdown on the password example, and I want to grep for space A to Z, cut -d, and then sed to boil down and change the colons into spaces. And the last one I've got here is interesting, because this one is really fun. So this says awk, use the awk command, the field separator is colon, look for field 5, and that should not equal to this lower graph plus, and then field 7 should not equal to sync, halt, login, or shutdown, and then print just $1 and $5 out of the password example. Single command to do everything, no pipes. It's all done with a single command. This one's kind of entertaining, and we'll get to this later. Okay, now moving forward. Project 2. There's some caveats for using grep. Large repetition counts in the curly brace n-m construct may cause grep to use lots of memory. In addition, certain other obscure regular expressions require exponential time and space and may cause grep to run out of memory. As we've mentioned before in week 4, back references are very slow and may require exponential amounts of time to compute. And now we're getting ready to jump into Interactive Bash and Hello World. And in the remaining time in the first part, I want to show you where Hello World first showed up. Here we go. Hello World is usually the first example for any programming language. I've always wondered where it came from. Well, here we go back to Bell Labs. Brian Kernighan, remember Kernighan and Ritchie wrote the C programming guide? Actually wrote the first Hello World program as part of the documentation for the BCPL programming language developed by Martin Richards. BCPL was used while C was being developed at Bell Labs. So whoever wrote this comment was researching a book about the Alice programming environment, and then he corresponded with Professor Kernighan, who's actually alive and well and teaching, and they came back and said that it was part of the I/O section of the BCPL manual. But then it comes back down and says a little bit more. The C book was not in 72. The C book actually came out later. The B book was written in 72. The first edition of the C book, published in 78, which you've seen a copy of, and I've got one, there was a 1970 Bell Labs internal memorandum by Brian Kernighan, Programming in C, a tutorial that had that. And then there's also an I/O section to his 74 C tutorial that had the Hello World in it. And then someone else came back and said the first known instance of the usage of the words hello and world together in computer literature occurred earlier, in Kernighan's 1972 tutorial Introduction to the Language B, with the following code. Main, extern ABC, put char A, put char B, put char C, put char at the new line, right? So hello world. There you go. So that's hello world. And we'll start part 2 here in a moment.